Good morning, everyone. Thanks for coming out today to have a chat with us about Windows 8 support for Unity. I'd like to thank everybody who came out physically to the room and wants to sit here and talk with us. And I'd also like to extend a thanks to all the folks online who are also watching the live stream right now. So, as Corey mentioned a few minutes ago, I'm going to kind of give you guys a bit of a deeper dive into some of the trials and tribulations that we at Unity have gone through in porting Unity to Windows 8, to the Windows Store. So, but just a little bit about me. My name is Randy Spong. I am a field engineer with Unity Technologies. I've been at the company for about 2.5 years now, and I spend most of my time working pretty closely with a very wide variety of our customers. I work with our console customers, I work with our source code customers, and I've also spent a bunch of time working with Microsoft Studios on their publishing efforts for several Unity-based Windows 8 and Windows RT titles. And so I think that I have a couple interesting insights that I'll be able to share with you folks this afternoon. So let's talk about how we're actually going to do that. So the main thing we want to do here in this session is give all you folks in the room and all you folks online the tools you need, or the tool set you need, to be able to take your existing Unity project and get it over into the Windows Store for Windows 8, Windows RT, and eventually Windows Phone 8 as well. So the way I want to get you guys set up for that is rather than spending all my time in the editor and going over kind of details, I'd rather go very high level and allow some of our customers later this afternoon to really get you that nitty-gritty information you need to make those changes. So let's talk about the tool sets, the tools that I'm going to provide for you today. So the first off is I want you guys to be able to understand what is unique and interesting about Windows 8, Windows RT, the Windows Store in general, and the way we modified Unity to work for it. So we're going to go over that. Then we're going to go over what changes actually had to be made. Why is this platform different than other platforms Unity supports? And what might you guys have to do differently to get your games on there? And third, this last tool is giving you the tools you need to be able to make your game run awesome on the Windows Store platform, because there are definitely some differences that need to be taken into account. So with that said, let's go ahead and just dive into it. So I'm going to go ahead, like I said before, I'm going to give you the overview of Windows 8. I'm going to give you the overview of Unity for Windows 8. I'm going to give you some details on what code changes need to be made. I'm going to give you some details on how to optimize your title. And I'm going to give you some tips and tricks that you just need to keep in mind during your development project. So let's go ahead and just get through the agenda here and cover all these topics. First off, let's talk about what's new with Windows. So one thing that's really interesting with Windows 8 and Windows RT is that there is a massive, massive variety of different types of devices and form factors out there in the marketplace. And normally, this wouldn't really affect you so much, except for the fact that it is a much broader range than you're used to with Windows, because you have people with phones, you have people with tablets, you have people with laplets, you have them with sliders, laptops, desktops, all-in-ones, media centers. And all these devices have different screen sizes, they have different aspect ratios, they have different GPU capabilities, they have different CPU capabilities. They may even have different hardware capabilities in terms of interoperability. You'll find with Windows RT, this is an ARM-based device. It doesn't necessarily have all the same driver support as a usual Windows 8 desktop that you're used to. Another interesting thing about Windows 8 is the massive, massive focus that the Microsoft is placing on devices that are always connected and never plugged in. So that's also pretty interesting and new, because when you're talking about Windows development previously, normally you would say, oh, this thing's got a plug in the wall, it's got a big honking GPU, and we can just do whatever we want. It'll just kind of work, right? That's not the case anymore. These are very, very tight devices nowadays. You want this person to be able to be sitting on the bus with his tablet out and have a good gameplay experience when he's only using, 2 watts of power. That's going to be an interesting challenge. So I want to give you some tools to be able to deal with that. Other really important thing, x86 and ARM. So you're talking 2 completely different chipset architectures. So this is a lot of work that we had to go through, but luckily we did the hard work so that you don't have to. And we'll cover exactly how it is that we were able to make x86 and ARM work from the same Unity project. But first, I want to cover a little bit more on this range of performance we've got for Windows 8. Because when you look at Windows 8 and Windows RT, you see that you have these Surface devices, these tablet devices, and they look a lot like Windows 8, and they behave a lot like Windows 8, but it's not. It's Windows RT, and it's running on ARM. It's running on a battery-powered, high-mobility device that needs to be very, very stingy with the amount of electricity it uses. So when we're talking about this Microsoft Surface using the NVIDIA Tegra 3 chipset, we're talking about a device that's using half a watt on the CPU and another half watt on the GPU. So when you're talking about overall graphical capabilities and overall CPU capabilities, you see a delta that's pretty massive between that and desktop devices. For example, a modern gaming desktop might have, let's say, a GeForce 650 in it. And that's going to be running in the 800 gigaflops range, of 800 billion floating point operations per second. You look at a laptop, a modern gaming laptop might have a GeForce 650M. That's running maybe 600 gigaflops. It's still within range. It's only 25% slower than a desktop machine, or than a comparable desktop machine. But then you look at your phones and your tablets. Now, these are mobile devices. These are not desktop devices. So what happens when you go from a GPU that's using 150 watts of power to a GPU that's using half a watt of power? You get a lot less power. So when you think about doing tablets, doing Windows RT development, it is incredibly important for you guys to remember that these are closer to phones than desktops. And that's because these devices are not plugged in. These are mobile devices. They're using the same kind of technology that phones are using. Now, it's cool because we get to share a lot between desktop and RT and phone. But it also, it's very tricky because you want to keep, porting your game from desktop to RT, and you don't think that much should change. That's not true. Treat it like a mobile device. Another couple interesting differences. With Windows 8 and Windows RT, this is a touch-capable OS. And this actually does have significant impact on your game design implementation. For iOS and Android, or for any of the other platforms we support, like maybe the upcoming BlackBerry 10, we only have to worry about touch. For PC, Mac, and Linux, we only have to worry about keyboard and mouse and game peripherals. For Windows 8 and Windows RT, you need to worry about both of those, because on this Surface, you have a trackpad and you have a touch screen. And so you have to be able to deal with the fact that a user is going to be going in there and actually possibly touching the screen while using the trackpad at the same time. So you got to cover that. Another interesting point is the minimum device resolution. There's a pretty wide range here as well. For Windows RT, the minimum resolution at this point in time is 1366 by 768. That's not very huge, especially when you consider that a desktop machine might be 2560 by 1440. You have talking 4 times the pixels. So that's an important thing to take into account as well. And the other really, really important difference here between Windows 8 and Windows RT that you want to keep into account, with Windows 8, you have a wide range of DirectX feature levels. You'll have DX9, typically 9.3, or DX10, or DX11, or 11.1 even. With Windows RT, you're only guaranteed DirectX 9.1. And the difference there is on a Microsoft Surface, for example, which is using feature level 9.1, you don't get 4K textures. You only have 2048 by 2048 textures. And you also don't get simultaneous or multiple render targets. So some of those interesting visual effects you're doing, like rendering out depth and normals and diffuse the different textures and recombining them on screen, isn't really going to work on a Windows RT device. Things to keep into account. So now that we kind of understand a little bit about more how Windows is different, let's talk about how Unity is different as well. So first off, and this is actually a really, really big thing, and I've talked about this in the past, is that Unity for the Windows Store, actually let me back up just a second. Unity in general, for all other platforms except for Flash, is built on the Mono framework, which is an open source implementation of Microsoft's .NET runtime. The Mono framework has allowed us in the past to very quickly and easily port Unity to additional platforms. But with Microsoft's Windows 8 and Windows RT, we had to do something a little bit differently because there are some architectural constraints in place to maximize performance and to maximize battery life for Windows 8 and RT. That we basically were not allowed to use certain features that enable us to use ARM. So we did, in fact, have to make the switch to .NET. There are some advantages here, and there are some disadvantages here. In general, we do the hard work so you don't have to, but there are some things you guys do need to take into account in terms of Unity being on .NET for Windows 8 and Windows RT versus iOS and Android being on Mono, and we'll talk about that. One of those things is, for example, you do have to deal with different DLL or plugin types between platforms. So it's a little bit of bifurcation there, but it's manageable. And again, dealing with input, you got to handle touchpad and trackpad trackpad and mouse at the same time. We'll deal with that as well. Other things that are currently going on with Unity for Windows 8 and RT. So as you guys know, we're currently in beta for the Windows Store add-on for Unity. So a number of these things will be getting resolved as we move forward, but some of them are kind of architectural constraints. First off, we do not currently have a 64-bit app build for Unity for Windows 8. We will not, at least for the foreseeable future, have one for Windows RT, but that's because ARM chips are, of course, 32-bit devices. Most of these mobile devices are. So that may change in the future, but for now, 32-bit on RT, and until we get it implemented, 32-bit on Windows 8. The other one, as Corey mentioned a few minutes ago, JavaScript and Boo are not currently supported for submitting to the Windows Store. They do run locally, and we're working on getting them to getting them WAC compliant, but at the moment, it's C# only for shipping your app. Other things that aren't fully implemented, we're not currently planning on implementing the network class. That's our RackNet peer-to-peer and client-server networking. We do have already completely implemented the www class. So doing your HTTP, HTTPS, FTP, file://, loading all those assets. Actually, I should correct myself. You cannot use the file resource locator at Windows Store, but there is another way to do it. But for all those things, that's all perfectly fine. That works great. Asset bundles, streaming live, everything's wonderful. For the networking, you're going to want to use a .NET Socket server. Another feature that's currently not working is cloth in PhysX. I'm actually not sure at this point in time if we're going to go ahead and implement that. Although, frankly, for like a Windows RT type device, you probably don't want to be using dynamic cloth anyway, so it's usually OK. And for some reason, odd man out, we haven't implemented microphone support in our script API. I'm sure we will at some point, but for now, go ahead and use a WinRT component and just register it that way. Another couple interesting things right now, you cannot animate script variables. This one is actually an interesting one because it's an architectural limitation. We actually depend on an interesting behavior of Mono to allow us to do this really strange, hacky thing that allows this to happen. We can't do that on .NET. So this may, in fact, stay that way. If you're using script variable animation, you may want to keep that one in mind because it's not possible on Windows 8 and RT at this point in time. Animation event callbacks. This one is much more likely to be something that we can fix over time. But at the moment, your animation events cannot have arguments or just have the one animation event. Like having multi-events or like passing a float or a bool to your animation events, not currently working. Game object send message. This one is another one that we just have to kind of do the grind on to get working. But what's going on here is that we don't have type conversion at the moment. So if you pass some sort of complex data type, it needs to match exactly the receiving function's data types. String equals string, float equals float, et cetera. There's no conversion or typecasting there. And this is just a driver issue with the Tegra chipset at this point in time. But for DirectX devices, like say the Surface, that are using feature level 9.1 with the NVIDIA drivers, no fog at this point in time. It is OK, though, because you can implement it in your own shaders. Now, there are some good things about Windows 8, Windows RT as well. Otherwise, I wouldn't be here in all likelihood. As Corey was talking about, but didn't quite get to demonstrate, but it's OK because you'll be seeing it later today, you can, in fact, debug your script code in Visual Studio. And you get all of those amazing Visual Studio tools. For those of you who have been trucking with MonoDevelop for the past couple of years, I think you're all probably pretty excited about being able to use Visual Studio for all of your development and debugging work. Next one, and this for the folks who've been developing on iOS, this is especially cool because we're actually exporting a Visual Studio project instead of just, say, copying your game data files with a pre-built executable. This gives you a lot more flexibility in how you integrate plugins and customize your project, just like with iOS. Because now, if you're integrating all of the Prime 31 plugins or Windows 8 specific support plugins, all this can be done much more easily after the Unity build process completes. So you can go ahead and modify that Visual Studio project, fix up references, insert additional code, add other plugins, and then go ahead and customize and build. That's really, really convenient. And, of course, Windows Phone 8, which we'll be talking about a little bit later today, pretty much just works with the vast majority of your code. That's because Windows RT and Windows Phone 8 share almost the entire kernel and a fair chunk of the shell code as well. And so all the stuff we're outputting for Windows RT support for ARM chipsets is just consumed by the Windows Phone 8 OS. There are some differences that we'll talk about, but it's actually like really pleasantly surprising how little of a difference there is. So, differences. Let's talk about changing your code in order to work well with Windows 8 and Windows RT. So first off, there's a pretty big change that happened. It was likely about a year ago. Microsoft made a pretty big change during development of Windows 8. What they did was went through a huge swath of the Win32 API and the .NET APIs. And they said, you know what, these are old and crufty, or they're security risks, or they're performance hogs, or maybe they don't have any synchronous versions. And they basically just cut them all off. So they took thousands of APIs, and they said, you can't use these on Windows 8 and Windows RT. Now, it's a painful switch for us now, absolutely. But I mean, long term, it's a good thing. But we do have to deal with that at this point in time. So let's talk in a few minutes here about some of the more important code changes that were made, some of the more important disallowed APIs that you have to work around. And the other one, of course, is because the Unity editor is built on Mono, but the Windows Store runtime for Unity is built on .NET, your plugin code for runtime has to be different than your plugin code for the editor. So we'll talk about that as well and how you can actually get your plugins to work in both bid play mode and deployed. All right, let's talk about disallowed Windows APIs. So the big ones, the big elephants in the room are, of course, hash table and array list. A lot of code uses these. Luckily, these guys really are kind of deprecated. I'm going to step back there. So they're really specializations of other data types that are still usable. So that's not actually too bad. XML, we'll talk about that in a minute. But a lot of the XML APIs were deprecated and disallowed in favor of other ones. It's all still there. You just have to change your code. Threading changed a little bit more significantly, but I think it's for the better. And we'll talk about that just a little bit. And then, of course, all the Win32 functions. This shouldn't affect you if you're just doing user scripting in Unity. But if you're writing plugins that are doing custom Win32 or even CRT code, this can be pretty impactful. So you'll want to look at some of the resources I've pulled together to see what's changed there. So going back to the list, hash table. Hash table is a dictionary. It's just a special kind of dictionary. So this one's not that bad. All you got to do is just change your hash table references to dictionary references. The only thing you have to worry about is if you are not using homogeneous types in your hash table. Because a dictionary is templated, you have to declare the types that are going to be stored in the key and the value pair in advance. So if you're using heterogeneous data types in your hash table, you're going to have some refactoring to do to use multiple dictionaries. Most folks aren't doing that, so it's usually not a problem. Our experience with the folks who have been doing titles for the Microsoft Studios publishing, actually one or two of them will be talking later today, have not run into that problem. They were just able to kind of change things out and it kept going. Array list is also pretty simple. This one is a little bit more tricky just because with an array list you have two ways to index into it. You can either iterate through it or you can just do array element indexing. These are mutually incompatible with most data structures. So if you switch to a dictionary or a list, you're potentially going to lose some flexibility and possibly some performance. For most applications, it's really not much of an issue at all. So I would say that make the change, and if you see it in the profiler being a problem, then refactor it. Otherwise, just switch to a dictionary or a list and move on and optimize the important stuff. XML. Really, you shouldn't use XML. This is all I got to say about that one. No, I'll say a little bit more. So the deal here is XML is a very heavyweight format. It's a data transport format, but it's very highly decorated, and it also is kind of bloaty. At the moment, we don't have code stripping on Windows 8, but I'm sure we'll be adding it. And once we do, you'll be able to save a few megabytes by not using XML in your runtime memory size. But if you are using XML, you're going to have to pay the price for that. But I highly recommend using this opportunity here of being forced to change your APIs to think about other transport formats, maybe an optimized binary format or JSON or YAML. These guys are much more lightweight. They're smaller on disk, they're smaller across the network, and they're faster to load from storage and parse.
You've got existing property list formats, which are XML. They can also be compiled binary. Do you know if there's a way to use binaryplists?
So the question is, if you have existing property lists with XML data or serial or text XML data, is there a way to convert or to consume those in binary? I am not familiar with the XML APIs in .NET, so I cannot answer that one offhand, unfortunately. That said, in the general case, there's pretty much nothing that's off the table when it comes to file types in Unity. Worst case scenario, you write your own parser, or you find a C# library for someone who's already done it, if it's not already there in the .NET APIs.
WinRT has XML APIs. It's just not the same type that you have. So you still be able to read your XML files. You just got to use a different API.
Yes. So what Jaime said there is that, as you can see on the screen here, yes, system.xml.xml document and a number of these accessors and methods aren't there, but system.xml.link is there. And so you can still load up your XML documents and parse them and query them, and everything just works, but you'd have to change your APIs. So yeah, it is definitely, all that stuff is still there. They just have eliminated a number of the convenience APIs that folks tend to use. So I'm just reading this question here to see if this is a good time for it to come out. Why not? So Paul online asks, what about third-party libraries? If there is a library, such as Exit Games Photon networking library for Unity and Windows RT, which should I use for my game to build for Windows Store apps? Yes. So for third-party networking libraries specifically, a number of our partners, Exit Games Photon, SmartFox Smart Server, Ulink, and I always blank on the fourth one, ElectroTank's ElectroServer. These are all great .NET Socket servers, which have C# integrations into Unity, and these just continue to work in Windows 8 and Windows RT. So if you do need client-server peer-to-peer networking, or actually large-scale MMO networking, which is where these guys originally came from, look into those third-party solutions because they're already working and they're already in use by many different companies. Next one, threading. So this one is interesting because you can't just say create thread anymore, whatever the .NET equivalent is. What you should do now is use thread pools. The cool thing about thread pools is they're actually a lot more convenient than just regular threading, because now you're talking about you could just set up jobs and tell it to execute, and it goes ahead and just kind of figures everything out. Dealing with process affinity masks and figuring out which CPU to use and balancing everything yourself, frankly, most folks don't need to worry about that kind of detail, and it can tend to kind of get them tangled up because you don't know what the OS is doing, you don't know what Unity is doing with its CPU balancing. So go ahead and just let the thread pools take care of that. So I would say, dig into the documentation a little bit, get familiar with them, and convert your existing use of threads and your scripts and your plugins into thread pools. It's a bit of work, but trust me, it's worth the effort. For the Win32 APIs, this tends to not affect most folks. I think this is really much more of a big deal for us at Unity. But just in case you're curious, there are several thousand, maybe like 3,000 or 4,000 possibly, APIs in the original Win32 API that are blacklisted on Windows 8 and Windows RT. And for a variety of reasons, they're deprecated, there's .NET equivalents, there are performance issues, there's security issues, all sorts of reasons why. But the main thing is if you're writing DLLs and you're using Win32 functions, a lot of those are not going to pass certification when you attempt to submit your game. So it's very important to run the WAC all the time. We'll talk about that in a minute. But it's an interesting story here, what happened with the Win32 APIs for Unity, because let's say about a year ago, maybe 14 months ago, we actually had a fully functional implementation of Unity for Windows 8, and it was running awesomely. And then Microsoft released Developer Preview 6, which blacklisted all these APIs, and that's kind of when we realized that doing things like garbage collection was no longer possible with Mono. So that's why we kind of had to start thinking about using .NET for Unity, and that's where all these changes kind of came from. But at the end of the day, I think we're going to get a lot more flexibility out of this, especially if we say doing something we're thinking about, no promises, but is maybe switching the editor over to .NET. And then maybe letting you debug your script code in the editor and use WinRT components in the editor. And that way you potentially have a reunified experience with Unity on Windows 8 and Windows RT in the future. Once again, no promises, but these are kind of some of the things we're thinking about as a result of these changes Microsoft has made to move the platform forward. So next one up that I mentioned was plugins. So using plugins is typically pretty simple on most platforms. I think one of the exceptions is iOS, where you have to do a little bit of hackery and using static libraries in the project. But like say for Android or for Mac and Windows 7, all you have to do is build yourself an unmanaged DLL and drop it in the plugins folder in the project and write a little bit of code in your scripts and call that function. Everything's great. It's a bit more complicated with Windows 8. And this is one of those kind of workflow things you have to, I think one of our customers from Fling Theory is going to talk about later this afternoon is how to deal with this. So I'm going to go ahead and not get too much in the details, but I do want to prep you for it. So what's going on here is, like I said before, Windows 8 is a .NET environment. Windows Store apps built by Unity are in the .NET environment. The Unity editor is a Mono environment. Mono and .NET, while they're both implementations of the .NET specification, are not exactly compatible from that perspective. So when you build an unmanaged native code DLL, that may be using functionality that's not going to pass the whack because it's using blacklisted APIs. So while your game will run fine locally, when you attempt to submit it, it's going to blow out. So what you have to do instead is take all that code and build it into a WinRT component. Cool thing is most of that code just translates directly over, except for the stuff that's not WAC compliant. So you just refactor that. But once you've built that into an WinRT component, now that component can no longer be consumed by the Unity editor. So what you have to do is basically you maintain two wrapper code bases. One that you can build your plugin code into a WinRT component, and the other where you can build it into a regular unmanaged DLL. And that allows you to still have that unmanaged DLL in the editor's plugins folder and still use play mode. But then when you actually build, it actually uses instead the WinRT component. And we actually handle that automatically if you name the files the same file name. So that's actually pretty well supported. Obviously, there's some design considerations that I think one of the guys later today is going to go over. So we'll let him cover that. But this is kind of a big one to keep in mind for your third-party code. All right, so let's start talking about performance optimizations. So as I was mentioning, Windows RT definitely does have some, some overhead. I'm sorry, not overhead, but some performance ceilings based on the fact that it is a highly mobile operating system for highly mobile devices. In addition, one change that Microsoft made to Windows 8 during development for security reasons was to add some extra logic and checking to interop between unmanaged and managed code. And that way they can verify that there's no security issues here. Now, the downside of a highly secure OS is they do tend to be a little bit slower than highly insecure OSs. But I think at the end of the day, we probably all want our OSs to not be terribly exploitable and lose all our information. So we're just going to go ahead and take that hit. But what it means is you're going to find that when you're doing maybe some lazy coding, it's not going to perform as well as on other platforms because of that interop cost for the security. So what you're going to have to do is basically find the hotspots in your code where you are doing too much interop, calling too many Unity engine APIs, making too many component references, GameObject.transform, et cetera, and strip those out. So let's talk about a couple ways you can do that. First off, component caching. So when you're just talking about referencing random components, most platforms that isn't that bad. You see this code all over the place, right? You're constantly just referencing dot references of game objects. Usually it's fine. It adds up. It adds up in any platform. It just happens to add up a little bit faster on Windows 8 and Windows RT. So instead of directly referencing components, you're going to want to cache those references off. So a better way to do that is to, if you know you need to re-access something multiple times a frame or over multiple frames, go ahead and cache off a reference to that object, such as declare a transform variable, assign your actual transform reference into that, and use that reference. And the reason is because this code, transform.translate, GameObject.transform.translate, that's calling in to unmanaged code. It's doing it twice, actually. So when you make the transform reference, we have to go into C++, and we have to search the game object and find the correct component that matches that transform and then return it into managed code. And then you call translate, we go back into unmanaged code again to actually execute that function in C++, because of course Unity is 95% C++. It just so happens that all of your interface with it is in C#, JavaScript, or Boo. But at the end of the day, every call you make eventually trickles down into our C++ code. So you want to minimize the number of those bind points. So how you do that? Let's cut that in half. Let's go ahead and cache that transform and only call the translate function into C++. And by the way, this, not that bad. This is terrible. Calling Unity functions in loops or making component references in loops, doing it dozens, hundreds, or even thousands of times per frame will destroy your performance. Don't do it, because it's terrible. All right, next one up. So another thing that's actually really, really expensive on all platforms, but again, is more noticeable on 8 and RT, is the cost of instantiate and destroy for game objects. So what you're going to find is when you are, say, have a particle system-based, I don't know, bullet effect, where if you're actually firing a weapon and each of those bullets are individual particle systems, that is really, really bad, because you're going to be many times per frame, potentially dozens or hundreds, instantiating a brand new game object and destroying the old game objects. And with the cost of instantiation and destroy, that can cripple your frame rate pretty quick. Now, if you implement game object pooling, such as by implementing a very simple pool manager that just allows you to store off game objects when they're not in use and then reconfigure them and reuse them later on, you're going to get a massive, massive boost in performance. So you absolutely want to, and I just realized I've been standing like in front of everybody in the screen here, but you absolutely want to go ahead and implement pooling. When you're done with a game object, instead of calling destroy, pass it to the pool manager. Your pool manager can deactivate it, and it can just save a copy. And then when you need a new game object, grab it from the pool manager instead of instantiating one. Big, big savings. Other cool things you can do here are potentially even getting a little more fine-grained and getting particular types of game objects. Because let's say if you have an RPG and you have different monster types which use different components or scripts, like say you have orcs and trolls and goblins. You don't want to retrieve an orc game object if you're going to instantiate it as a troll, because maybe you have to add and remove some components, and that's expensive too. So maybe what you want to do there is actually specialize your game object references and say, get me the closest thing to a troll. And it will go through and say, do I have anything in my list that actually used to be a troll? Oh, I do. Here's this game object. And then all you need to do is just reset values instead of adding or removing components. So you can get a lot more fine-grained here and really get a massive boost in performance by engaging in game object pooling. Another important thing here, with these mobile OSs, like Windows RT, you're going to find very frequently that you're going to be heavily CPU bound. And that's because these CPUs are using relatively low wattage. They have a lot of power behind them. And so you want to minimize the amount of things that Unity is doing on the CPU side so that you have room for your code. So instead of, say, having us manage draw calls on the CPU, and which means you're now competing with us for the CPU time, you want to get those draw calls onto the GPU. The only way to do that is to minimize the number of draw calls. You've got to use batching. So dynamic batching is handy because it kind of just works. The problem with dynamic batching is it doesn't work all that well. So it's got a limit, for example, of 900 vertex attributes. That means if you're using a vertex position, a normal, and a UV, like pretty much anything nowadays, your objects that are dynamically batchable have a max vertex count of 300. Those are basically just detail meshes. So you're going to find a lot for the complex geometry, it's just not dynamically batchable. Other interesting issues there, objects, like say you have an object that is uniformly scaled, 1, and an object that is scaled up to 2. Those cannot dynamically batch together. We can only batch things that have the exact same scale or things that are all using non-uniform scale. But these are very important things to keep into account when you're keeping your draw calls low. The other thing about dynamic batching that's interesting is it costs CPU time to save CPU time. So dynamic batching, we have to do a bunch of setup work at runtime in order to figure out what's dynamically batchable and then batch them together and then send them off the GPU. So you're only getting a partial savings there with dynamic batching. Some of the ways around this. Of course, static batching. It's more work, but it's much more savings. And the reason is because we're doing this at build time. So instead of at runtime going through the draw list and figuring, oh, this looks like that, we can actually share a draw call. We do that in the editor. And so draw call setup no longer happens in this way in the runtime. Instead, it's already all prepared, which means you get a big savings on CPU time, which on Windows 8 and Windows RT is very, very important. Some limitations with static batching, though. The objects have to be static. They can't move, they can't rotate, they can't scale. They have to actually be in the scene. You can't be instantiating and destroying all the time. That doesn't work with static batching. They have to be static objects. The other interesting side effect of static batching, it uses a lot of memory. For most devices nowadays, especially on the Windows 8, Windows RT, and Windows Phone 8 side, you're in pretty good shape because all these devices have 2+ gigs of RAM. It's really great. Compare that to the 256 or 512 days when just having your game loaded at all, you was using 80 to 100 megabytes, and then you were done. That's a pretty good situation now. It is something to keep into account, though. One thing you see, like say you're using the terrain system, which you really should on a mobile device. We'll talk about that. But if you're using the terrain system and you have a bunch of trees on there, don't mark the trees as static. That will use hundreds of megs of memory for all of those objects. So you want to keep that balance in mind. Try it out, mark things as static, do a build, see how it performs. Are you using too much memory? Okay, turn some things off. You got to find that balance of memory consumption versus CPU usage. Another really important thing you can do here to minimize your draw calls is to use texture atlasing. So, batching only works so well. But at the end of the day, you have to share materials. You have to have the same textures. You have to have the same shaders. If you don't have all these pieces of draw state shared, there's nothing Unity can do to batch them. So, and again, because on Windows RT, this is a mobile operating system, you need to use every tool in the toolkit to get performance up. So, go on to the documentation site on the website and look up our utilities for doing texture atlasing and combining these textures so you can share draw calls. Or go to the asset store and find packages that are already on there that are going to help you set up your texture atlasing. What that allows you to do, though, is, again, to share draw calls. You can have your different objects with completely different textures, but those textures are combined in memory, and now you're just using UV mapping. It's just one draw call now. And this is a massive, massive savings you can make here. All right, so let's once we're done talking about things you should do, let's talk about things you shouldn't do. So again, these are mobile operating systems. Treat them like iOS or Android, and you will be much, much more happy at the end of the day. You should not be using desktop shaders on Windows RT. Windows RT is a mobile operating system. Even on Windows 8, you may want to think about using mobile shaders, because Windows 8, well, guess what? Most of these devices nowadays aren't desktops. I don't see anyone in this room with a desktop. I see everyone in this room with a laptop or a tablet. So think about where people are going to be playing your game. Are they playing on a desktop at home on their big old Steam rig? Probably not nowadays. I think most folks are doing mobile gaming experiences. So think about battery consumption, think about device size, et cetera, when you're making your game, and about where the majority of folks are using it. Terrain system. I don't know if you guys remember this, but it was about, I think, a year and a half ago when we originally allowed use of the terrain system on mobile devices. There's a number of us in the company who still think it was a bad idea to do that because terrains are hideously expensive. There are very few phones or tablets that can really effectively run a game that makes heavy use of terrains. They're just really too expensive. They're great because they kind of do it all. You can just kind of set them up and paint and drop objects down, but at the end of the day, convenience versus performance. You got to weigh that. Real-time shadows. This is another one that we unlocked on mobile devices pretty recently. Most mobile devices still cannot handle it very effectively. When you're talking about minimizing draw calls and minimizing overdraw and minimizing CPU time, rendering shadows, you're talking about like making 6+ passes per shadowed pixel. If you're not using real-time shadows, you're talking about making 6 times fewer draws on those pixels, maybe more. It adds up really fast. If you really need to, consider using real-time shadows on your main character. And that way, you can use light maps and static shadows and maybe projectors, et cetera, for all the rest of the stuff. Only use the real-time shadows where it truly matters.
On the, well, since you're using a Tegra 3, is
You know what? I actually do not know the answer to that offhand. We'll have to look that one up.
Can you repeat the question?
So the question from Juan was, do real-time shadows actually work on Tegra 3-based Windows RT devices? And I was caught a little bit flat-footed because I really should know the answer to that one, but I don't. I'm getting a head shake from Jaime. So what I'm hearing here is on the Tegras with the DirectX 9.1 is that you don't have real-time shadows anyway. So don't worry about it. It's all good. That's okay though, because I mean, honestly, this is going to change pretty quickly. You know, the Tegra 3 is a great chipset, but it is nearing its end of life for these higher end devices, right? And so you're going to find that when the Tegra 4s come out, you're going to have a much wider range of options and a much higher performance ceiling that you can work with. But today, you got to deal with what's out there. And a lot of these devices are, in fact, using these mobile chipsets of a year ago. So that's something to keep in mind. The other thing, because we're using mobile chipsets, you want to avoid overdraw. Again, just like shadows, if you actually had support for them. If you're doing, say, dense particle systems, you're rendering on these same pixels constantly because these particles typically have alpha, which means you have one particle in front of another, in front of another, in front of another, with the scene behind it, et cetera. And you're talking about rendering these individual pixels so many times. And all these mobile devices are highly fill rate constrained. This cannot be overstated enough, is you need to avoid overblowing your fill rate. So with particle systems, keep it simple, keep it small. Consider using sprite packing techniques. There's actually some packages on the asset store for this, for rendering particle systems into multiple sprites. And then you just play back the sprites. What happens here is you get less overdraw because within that individual sprite, there is no overdraw in there. There's only overdraw into the scene behind it. So that can massively, massively reduce your performance overhead. Another one that's interesting is when you're doing sprites. Corey had a question earlier today about 2D support in Unity. So we don't have a lot of tools that make it as easy as other things in Unity. But I think that's one of the interesting misconceptions is, Unity has made 3D so easy that now 2D looks hard in comparison. But really 2D it's still 2D. It's just not as easy as the rest of the stuff we've done. Maybe we'll fix that in the future. But for now, you want to think about some things like doing sprite meshes. So instead, what you can see here on the left is a bad way to do things on mobile devices. So you can see here, I'm going to turn around. I don't normally try and do this, but you can see here this frame. This is 2 polygons on this panda. And about, 35% of these pixels are useless. These pixels are being drawn with transparency for no reason whatsoever. So when you start talking about having lots of 2D sprites moving over each other all the time, you're talking about lots of overdraw. Well, guess what? These are 3D GPUs. GPUs are good at geometry. Maybe they're bad at fill rate, but what you should do here, tessellate that mesh. Avoid overdrawn pixels. So here, 35 whatever % of those pixels are actually being rendered for no reason. Here, I don't know, there's a pixel here and a pixel here maybe, and about 10 or 15 there. But it's a lot less. So definitely think about that. And again, lots of tools on the asset store, things you can do yourselves as well. Another interesting thing here, when you want to talk about optimizing your device for a mobile operating system, we have an incredible quantity of resources on our website. I actually am pleasantly surprised every time I go into the manual at how much new stuff has been added. For example, now we have a feature on inside the documentation talking about techniques that several game developers have used for some of the more beautiful titles on the app stores. And they're actually going through and talking about the individual techniques these guys were using and how to recreate them. Go to the manual, check it out. And we'll actually, we'll be providing copies of this presentation for both all the folks in the room and all the folks online, so that way you can actually go in and check out all the links in the presentation. So, we've talked about Windows 8, how it differs from previous operating systems and other operating systems. We've talked about Unity and how it's changed a bit. We've talked about doing some performance optimization specific to Windows 8 and Windows RT. Let's talk about some generic best practices. Things you should be doing, from the day you start your porting project all the way up until, well, frankly, forever, because once you ship, that's only the beginning, right? But there's a couple important things here. First off, you want to use an animated loading screen. So, because there's such a wide range of performance profiles and hardware types in the Windows ecosystem, you don't know what specific device your game is going to be running on. You don't even know that your game is going to be running from high-speed flash storage. Maybe it'll be running from a USB stick, which means loading times are a bit of a question mark. So it's very, very important if you want to pass the whack and you want to give people the best user experience possible, use a XAML project from Unity and implement an animated loading screen in XAML. And that way, as soon as your app actually takes focus and can run, you can turn on that animated loading screen and give the user some sense of interactivity and progress. This is really key. When you're talking about 30 second, possibly 30-second loading times for loading off of, say, USB storage or more, you need a user to be, feel engaged. I'm not going to go to the details here because actually one of our customers is going to go into the details later this afternoon, but keep that in mind. Another really important thing is because, again, of the wide range of hardware out there, when you pick the low end of what you're going to support, you need to test on that constantly. I see this time and time again, working with all these different customers on all these different platforms, that they give all their engineers and artists iPad 3s or iPad 4s or Surface Pros, and they tell them that the low-end spec is an iPad 1 or a 2 or a Surface. And that doesn't work because you need to be testing on your full device range. So frankly, what you should do is actually give low-end devices and trade them around your team. Make sure that folks are using different devices on a daily basis. It'll help you find issues. It'll help you maximize performance. It'll help you maximize beauty, et cetera. Get that ecosystem really into your office. There's a number of third-party testing services out there as well that have huge device labs that can go ahead and load up your game on all sorts of different hardware and tell you how it runs if you don't have the resources to get all those devices in-house. It's very important. And the next one, and possibly the most important one for porting your existing project to Windows 8, is constantly running the WAC tool. So when you're talking about starting from scratch with your project and refactoring huge swaths of code and rewriting things and pulling in brand new asset store plugins, and any one thing could potentially cause you to fail the WAC, you want to be running this all the time. You want to be running this daily, maybe even multiple times daily when you're in heavy coding time. So that's this is one of the most important things we've learned from our customers who've been working with Microsoft Studios and independently to publish their titles. Is you cannot pay close enough attention to the results of the WAC test. So do it all the time. All right. So here's what we covered. First off, Windows 8 and Windows RT. These are both mobile operating systems. A lot of devices can be plugged in, but they very frequently won't be. Touch is a first-class citizen. You need to always be ready to handle both touch and keyboard and mouse on any Windows 8 or Windows RT device. There's a huge range of form factors, which also implies a huge range of screen sizes and aspect ratios. There's a huge range of performance capabilities, which implies lots of testing needs to be done. For Unity, what's changed? Again, you need to handle input for both keyboard and mouse and touchscreen. Well, luckily, we've added a property for that. There's actually a property that we added which I cannot recall the name of offhand, that allows you to disable the trackpad from modifying the mouse position. So that way, when you call input.touches, you get your touch info. But when you call input.mouse position, you only get the mouse position as it was affected by the mouse of the trackpad. And that way, you can handle both at the same time. It's really cool. Native code plugins, you do have to rewrite them as WinRT components and also keep them as unmanaged plugins for use in the editor. You'll see some more trips and ticks. Something like that, later on today. For porting your existing code, you got to convert some data types. Again, keep it simple. Just convert your esoteric data types into dictionaries and see if those are actually performance issues. Because frequently enough, most of your game code, when it comes to using data structures, is not the bottleneck. The bottleneck is usually draw calls. It's usually GPU time. It's usually loading and instantiating and destroying, et cetera. So focus on those kind of things. Optimizing, there's a lot of things you can do here. I covered the tiniest little sliver of it today. But cache those component references. Don't make component references in loops. Don't call Unity Engine functions in loops. Try and batch up as much as possible and spread it across frames as well. Use texture atlases in order to share draw calls between objects with completely different textures. And don't use these big do-it-all features like the terrain system on these mobile operating systems. Those are real, just beefy desktop kind of features. And you can do all the same stuff with a little bit of tooling work with meshes. Think about the trade-off in convenience versus performance, right? And of course, hit the manual, check out our documentation, because there is so much new stuff in there talking specifically about how to optimize for mobile devices. The documentation that's shipped right now is iOS and Android. Well, guess what? All these concepts are equally applicable to Windows 8 and Windows RT. Why? Well, this Surface device is running a Tegra 3, the same thing as your Motorola Zoom 2 or any of these other Android devices, right? These chipsets are very similar. Same thing for Windows Phone. Windows Phone is running a Qualcomm chipset with an Adreno 225. You're going to see that in a lot of Android devices as well. So these tips and tricks are very applicable across all operating systems. And for best practices, make sure to test on the low-end devices, because if you don't, I can guarantee you it is going to run horribly when you first start testing it. You would be amazed at the difference between a low-end device and a high-end device in the tablet and phone market. And run the WAC constantly. Constantly. I mean, seriously, set up a batch script so that it runs every time you walk away from your desk. That way you have some WAC results to come back to. All right, and for the folks who are going to be checking these slides out after the presentations, I have a bunch of links in here. For example, the changes in supported APIs in Windows 8. I also have some links in here, just waiting for some pictures to get finished taking. I also have some links in here for the Unity stuff on optimization. If anyone online or in the room has not signed up for the Windows Store beta, you can do it by going to unity3d.com/beta/Windows Store apps, and we'll get you in there. And we also have some resources on here for doing optimization. And that's it. Thank you so much for your time, folks. Same lines as our current add-on programs. Are there any other questions for me? I covered all the topics that well, huh? All right, cool. Well, thanks a lot, folks.